Pre-Calc. It's problem number 7-123, letter C. And I want to, before I do it, I want to show you this math notes box on rates of change. So we were doing average rate of change, where you take the slope between 2 points, but as h gets smaller and smaller, it ends up like being this instantaneous rate of change. So this is in your math notes box, and so you see that we're going to take the limit. We're going to plug of f of you can say x plus h if you want to, minus f of x all over x plus h minus a. But these a's cancel out, so you just end up with this little part right here. And that's instantaneous rate of change, and that's what I'm going to use. That's what I've written. I've written that down right here. That's your IROC. Okay, this right here, this is IROC. So we're going to always use in this book, I think it's safe to say that if you just let h equal 0.001, then your answers will match what this book does. So on 7-123, letter C, it's talking about a boulder that falls off a cliff, and it has, this is our function that describes the boulder falling. And then so we're just going to talk about letter C. What's the instantaneous rate of change of the boulder's height at a certain time? So the t, that's kind of like the x values. It's the value that you plug in. So I've kind of written that down on the paper. So this is the time, this is the point that we're interested in finding out what's the average rate of change. So if I look up here, I've got f of x plus a plus h. It's kind of like y2 minus y1. So it's going to be this number plus h that I'm going to plug in right here. So if I do this number plus h, well, we just said h is 0.001, so instead of me writing a plus h and a bunch of stuff in here, I've just added that this t is like a, and I've added h to it, and I got 1.9, or I got this number. Okay, and then I'm going to plug without h, just f of x, the 1 point, that's a 392 in there. And I'm just going to put it in my calculator. But you can see that I did this in class. I put it in my calculator, and I had a little bit of a hassle. I had a hard time typing it out. What I did in class is I eliminated the 124s off of it, even though they're part of the function, and that's because if I just do my distributing is negative. I'll show you what happens. That's h, just from the formula. So you'll see that I end up with a positive 124 and a negative 124. So that happens so often that I am accustomed to just don't even write that part down. So basically I have to calculate these. So I'm going to try again to just do it all in one fell swoop on my calculator, and we'll see how I do. So I'm going to write negative 16 times, I'm going to, I think if I just push, hope this works, 1.393 wonder if I should push equals first. Plus 16 times Yay, it worked. So I think what I might have done in class is I didn't push equals, or maybe I pushed I don't know. I'm not sure what I pushed the wrong button when I was doing it in class. Anyway, this is about negative 44.56-ish. And so that's a rate of change, and I think we were in feet per second. So that's the instantaneous rate of change. It's the slope of the line tangent. The curve, by the way, probably looked something like that. Or maybe it didn't go up first. It was just dropped. I'm not sure. But if you draw a tangent line to the curve, wherever that t value is, and you find the slope of that line, that's what that is. It's the instantaneous rate of change.